Hello everyone. In this class, I want to explain about an important antenna parameter, vector effective length or effective height of the antenna. This concept helps us to understand how an antenna receives electromagnetic wave and converts them into voltage at its terminals. Okay, I'll explain. Take one transmitting antenna. That this transmitting antenna radiates electromagnetic wave into free space. Then these waves travels in space, this is all space, and gets collected by another receiving antenna. Okay. You know the radiation by the antenna is electromagnetic radiation consisting of electric field and magnetic fields. Okay. So when this receiving antenna receives these fields, the fields excites the electrons of the antenna. That excitation of the electrons produces a voltage at the terminals of receiving antenna. Okay. So that voltage depends on effective length of the antenna or effective height of the antenna. Okay. How much voltage is induced? How much voltage is induced at the receiving antenna? Voltage induced. Where the voltage gets induced, suppose take this dipole antenna. This is the dipole antenna. So whenever it receives the signal like this from a transmitting antenna, then these two are the two poles of the dipole antenna. Then these two poles gets excited, or the electrons of the poles gets excited by the electromagnetic radiation or electromagnetic field. Then those excitation of the electrons causes random movement of the electrons. That movement creates a voltage, and that voltage depends on the length of the antenna. It is not just a physical length. Length is called vector effective length or effective height of the antenna. Actually, the voltage induced in the receiving antenna depends on many things. Shape of the antenna, size of the antenna, direction of the incoming wave, polarization of the incoming wave, current distribution on the antenna. Okay. So the voltage induced in the receiving antenna depends on all these 5 factors. But all these 5 factors are included in the vector effective length or effective height of the antenna. That is the reason I told that the voltage induced in the receiving antenna will depends on the length of the antenna. That is called vector effective length or effective height of the antenna. Now I will define what is vector effective length. The ability of an antenna to convert induced electric field into open circuit voltage at its terminals. Ability of an antenna to convert induced electric field into open circuit voltage at its terminals. Okay. And another point, the vector effective length or effective height of the antenna is different from physical length. Thing is, suppose take this dipole antenna. The signal is coming like this. The dipole antenna receives this signal. From this end to this end, it is the physical length. But the length on which the current is distributed is called effective length or effective height of the antenna. Okay. Physical length and effective length are not same. Physical length is total length of the antenna. Effective length is the length which causes the current distribution. Okay. Means the current distribution is not in the entire length of the antenna. Okay. Another important point is vector effective length. The name itself indicates it is a vector. Why it is vector? The transmitting antenna radiates electromagnetic wave. That electromagnetic wave has direction. When the directed electromagnetic wave gets received by another receiving antenna, that response of the antenna is also having some direction. Means it also depends on direction. So that directed electromagnetic wave is causing the movement of electrons. So the electrons will also move in some direction. Okay, which induces some voltage. So that is the reason wave height is also a vector. We know induced electric field is a directive quantity, means it has direction. It depends on direction. So the open circuit voltage is also depending on direction. So that is the reason a vector effective length is a vector, means effective height is a vector. And that effective height is LE of theta comma phi, that is A theta cap of L theta of theta comma phi plus A phi cap of phi of theta comma phi. What is this theta and phi? Azimuthal and elevation. Vector effective length is a far field parameter. It is a far field region, means the wave propagates in radial direction. Okay, when the wave propagates in radial direction, means along AR, it has components along A theta and A phi. So that is the reason vector effective length, which is a far field quantity, is also depending on two parameters, theta and phi. So that is the reason, say this LE of theta comma phi, yes, it is the theta component and this is the phi component. Now we'll see this vector effective length in two cases. The first case, transmitting case. When a transmitting antenna radiates electric field, that electric field far field region is given by E theta A theta plus E phi A phi. These two are the components along theta and phi, because when the field is in far field region, direction is radial, so it has components along theta and phi. That is equal to minus j eta k in by 4 pi r Le into e power minus jkr. This expression, it has so many parameters. Eta, intrinsic impedance. For free space it is 377 ohms. K is a wave number, which is 2 pi by lambda. And In, current supplied to the transmitting antenna. R, distance from the transmitting antenna to the observing point. Okay. And Le is effective length of the transmitting antenna. And e power minus jkr, which causes phase delay. Okay. So this is the relation between Le, means the effective length of the transmitting antenna, and the radiated electric field. So it implies that the radiated electric field directly proportional to effective height. Okay, means high Le, high vector effective length causes high electric field. Means high electric field will be radiated if the effective length of the antenna is high. Low Le, if the effective length of the antenna is less, yes, it creates less EF. So that is about the transmitting case. In the receiving case, we can explain the effective length like this. How to interpret this effective length? See, the receiving antenna is receiving the signal from the transmitting antenna. So that received signal or that received electric field, yes, falls on the electrons of the antenna. Okay. Those electrons will move because of the field. That movement creates a voltage at the terminals of the antenna. That voltage is called VOC. VOC is EI dot LE. What I explained, take this as your dipole antenna, which is receiving. So when an electric field comes like this, it falls on the electrons of this. This is a conductor actually. This is made up of conductor. Antennas are made up of conductors. So when the electric field falls on the conductor, electrons will move. Okay. And see, this is the open circuit. Electrons are moving in the conductor. That movement creates a voltage. Okay. So that voltage is called open circuit voltage because it is open to the field. It is not connected to any other circuit. It is open to the free space. So it can receive the electromagnetic wave that gets radiated by the transmitting antenna. Okay. So here VOC is open circuit voltage. EI, incident electric field. So LE, effective length. Another important point is here, where is this incident electric field? This is your incident electric field. This field is from the transmitting antenna, remember. That field gets incident on the receiving antenna. So that voltage induced across the antenna terminals is given by incident electric field dot LE. Yes, this is dot, means this is dot product. Okay. So you know about the dot product. So from this dot product concept, okay, we can give some important points. See, we know about the dot product. If the dot product is between two quantities which are in same direction, they'll get maximum value. If the dot product is between two components which are in orthogonal directions, perpendicular directions, the dot product is 0. Okay, taking that reference, we can say if field and antenna both are vertically polarized, it gives maximum voltage. Maximum voltage gets induced. Okay, means antenna, field and antenna are vertically polarized, means this is EI, if it is vertically polarized. Antenna is also vertically polarized. If antenna is vertically polarized, then means the effective length of the antenna is a vertically polarized component. Okay. So if both are vertically polarized, you will get maximum voltage. If field is vertically polarized and antenna is horizontally polarized, then it gives minimum voltage. Okay. It means only the component of the electric field that is parallel to the antenna polarization contributes the voltage. Okay. So to get maximum voltage, the two quantities, incident electric field and the antenna polarizations, must be same. Means those two must be in same direction. Means those two must be in parallel. So what is the final important point? Polarization matching is essential for effective communication. Actually, in the concept of vector effective length or effective height of the antenna, so I explained. So this is the transmitting antenna which is radiating the signal, and that signal travels in space and gets received by the receiving antenna. And when that receiving antenna receives the electric field, that incident electric field falls on the electrons of the conductor. Where is the conductor? Antennas are made up of conductors. So that movement of the electron will create the voltage at the terminals of the receiving antenna, and that voltage depends on parameters like shape, size, direction of the incoming wave, polarization of the incoming wave, current distribution of the antenna. But all these things combinedly related in one term called vector effective length or effective height of the antenna, which is the ability of an antenna to convert induced electric field into open circuit voltage at its terminals. Okay. And physical length, effective length are not same. And vector effective length is a vector quantity, is a far field parameter. So it has component along theta and phi. I explained two cases for vector effective length, transmitting case and receiving case. The transmitting case, the radiated electric field is proportional to effective height. Okay. And in the receiving case, the induced voltage is depending on the effective length like EI dot LE. So as this is a dot product, to get maximum voltage, the incident electric field and the antenna must have same polarization, means there must be polarization matching. So this is the concept of effective height or vector effective length. Okay. So if vector effective length is high, then the transmitting antenna can radiate more signal. Okay. If the vector effective length is more, automatically the voltage induced in the receiving antenna is also more. Okay. So that's all. That's about vector effective length or effective height of the antenna. Okay. Thank you very much.